So we're asked to tell the value of the missing exponents. Here we have a product given where we have 12x to the 7th, y to the 9th. And so we must look at the exponent values in the monomial here. And we see that for x we're given 3. So in order to determine the value of the orange box, we would essentially just take the 7 in the product and subtract the 3. So 7 minus 3, that's going to be 4. So the value of the orange box there is 4. All right, so for the yellow box, same thing, except for 9. We look at the product, and the value is 9. And we're also given 4 in the first y value, so that's going to be 9 minus 4. And of course, that's 5. So the value of this yellow box is going to be 5 right there. All right, so that's how you would do that. In this one, we're asked to tell the value of the orange and yellow box, but this time you can see that we're asked to get the product of the coefficients, 6 and negative 5. So that's going to be in that yellow box, and of course that's negative 30. So 6 times negative 5 is negative 30. And the value of the orange box here, we have to look to the product w to the 9th, and we see we're given 7 for the exponent of negative 5w, and so we do 9 minus 7, and of course 2 is the value there. Okay. Finally, in this last slide, tell the values again of the orange and yellow boxes. So just look to the product. For v, we have 15 as an exponent. And we're given 8 in this part of the monomial for v there. So for the orange box, we do 15 minus 8. All right, and we come out, of course, with 7. And so the value of the orange box here is 7. Now to get the yellow box, we see w has a 5 associated with the product, and so we have a 1 here. So here's the tricky thing. There's no exponent shown, but it's actually understood it's 1, right? And so to get to 5, we're going to do 5 minus 1, so we know that the value is going to be 4 for that yellow box.